Hey everybody, my name is Aaron Williams. I'm here to talk to you today about network troubleshooting methodologies. This presentation should give you an overview as to how to successfully approach troubleshooting, different tools, different approaches, and overall just to help you be a better problem solver. The reason why I chose this as my topic is because I feel like this is arguably one of the most important tools that a network admin or someone working with networking can have. Um, Obviously, having the knowledge and the skills to be able to set things up correctly in the first place are huge. When you set things up correctly, when you configure things correctly, when the wiring is done correctly, and you document everything, that's going to make your job and everybody else's job a lot easier. If you aren't creating problems for yourself to fix, there are going to be a whole lot less problems. However, the reality is that no matter how well you set things up the first time, there are always going to be problems. There's always going to be those situations where people slip up and they misconfigure or make a mistake. There are always going to be situations where you have either hardware or software that is failing or things not working as you intended. And even outside of that, you're always going to have situations where you have end users or clients or whoever that is using the technology, and either through just a lack of education or lack of experience, they are either going to mess things up or they're going to not understand and they're going to need your help. In those situations, troubleshooting is going to be key. You need to be able to know where the problem is occurring and fix it to be able to minimize downtime and keep your network working as much as you possibly can. Before I get into the specific methodologies or any other steps to success, I just want to kind of cover this topic in broad strokes, and I want to talk about the overarching philosophy. This slide's information is going to pertain to any time you're troubleshooting, no matter what approach you're taking or what the problem is. These are the steps that you will use. So regardless of what the problem is, the first thing you want to be doing is looking at what symptoms are being experienced in your network. And this is either by you personally or by an end user or a client. What's going on that needs fixing? And this can range greatly from an end user not being able to send an email to the overall network running slower than it's supposed to be to having bottlenecks. Just all sorts of things can be found at this first step. So what you're just looking at what's going on. Once you've established what's going on, what the problem is, you want to isolate where that problem is occurring. And what I mean by where here is, where is it occurring on either the OSI model or the TCP IP model? When you're isolating it down to a layer, that makes the entire troubleshooting process so much easier. If you know that a problem's originating from, say, like the physical layer, you can focus your attention on the wires and the hardware and all that sort of stuff, rather than worrying about configurations or anything like that, or any sort of software. On the other hand, if you know that a problem is on the transport layer, you probably want to be looking at things like your access control lists and things like that. So if you can isolate where the problem is coming from, it makes it a whole lot easier to come up with a solution. Regardless of what you're talking about, you want to try to implement a solution, and that's not where things end. At that point, what you're going to want to do is you're going to want to evaluate your results. You're going to want to see what your solution did. If it fixed the problem and it didn't introduce any more problems, then great, that's exactly what you wanted. You're going to want to make sure you update your documentation and reflect the changes that you made. If it either doesn't fix the problem or it fixes your problem with unintended consequences, you're going to want to document that as well, but you're probably going to want to undo your changes and look for a change that can just fix that problem without having any other effects on your network. As I briefly touched on, documentation is very important to both ensuring that your network runs smooth to begin with, and it helps expedite the process of troubleshooting when things have gone wrong. If you have all your information laid out in a nice orderly fashion, all located in the same place, it can make fixing problems with your network a whole lot easier. One thing that you want to make sure you have documented is device configurations for every device in your network. And these configurations should list things like what kind of device it is, like whether it's a router or a switch or whatever, what operating system it's working under, what its addresses are, like its IP addresses, its MAC address. You want to be looking at things like where it's physically located, like what floor of a building is it on, all that sort of stuff. The next thing you want to make sure that you have documented is you want to have a physical topology. Now what this is going to be pretty much exactly what it sounds like. It is going to tell you about the physical nature of your network. That means where devices are physically located, like I just said with the device configurations, what room, what building, that sort of thing. It's going to talk about the physical connections that the wires have. It's really focused on the tangible aspects of your network. You also, on the other hand, want to have a documentation for the logical topology. And the logical topology is more focused on the networking aspect of things. It's going to be focusing on the IP addresses and the things that are required to be able to move packets around your network. As you can see here on the left, we have a example of a physical topology that is focused way more on where the devices are located, and then on the right you have more of a logical topology with listing IP addresses. Finally, with your documentation, and this is a very important thing that you may not necessarily think about off the top of your head, is you need to have an established baseline for your network. You need to know what your network acts like on a normal day to know if the traffic is abnormal. If you don't know what your network operates like under normal conditions, how can you say that something may be wrong or there is unexpected delay? It could possibly be that when the network was implemented, that delay was always there. So you need to make sure that you have a baseline, you understand what the network does under normal conditions so that you can accurately diagnose whether or not there is an issue and whether that issue is abnormal for your network. Before we talk about the different methodologies to troubleshoot your network, I need to talk about the OSI model. Because no matter what troubleshooting methodology you're using, these 7 layers are going to be key to solving your problem. So I just want to kind of go over each layer and talk about what sort of symptoms you might be experiencing if you think the problem's at this layer, and what sort of things could be causing that. Starting with the physical layer is exactly like what it sounds like. It's your actual tangible part of your network. And one of the most common symptoms if you're having an issue at this layer is that your network is performing below its baseline. You're noticing that your traffic isn't going as quickly as it should, and you're losing connectivity because of it. So some of the biggest causes with this are going to be either you have something powered off, or you have a server overloaded, or something like your cabling's bad or disconnected. The second layer of the OSI model is the data link layer, and you have some pretty specific signs if you have an issue here. Like the physical layer, your network could be operating below baseline. You could have frames that are reaching their destination, but they're taking a really roundabout path. You could have loops going on in your network. You could have too large of a broadcast domain. Really, how you'll diagnose those problems is either through error messages, or if you do like an extended ping to see that even though frames are arriving successfully, some of them are dropping. For the network layer, typically what you're going to be looking for is either a total or partial failure of the network. And basically what that means is either your network's just completely non-functional, or there are pieces of it that aren't working. Like you have specific traffic that isn't working, either because of configuration or because a link is down. For the transport layer, your most common errors are going to be either with your access control list or with your NAT configurations. I would say especially your access control lists, there can be a lot of misconfiguration going on there. Because of the order of your entries, or things like you've messed up wildcard masks like that. If you suspect you have a error at your transport layer, you really want to make sure you look in at your access control list. For the session, presentation, and application layers, I'm just going to kind of lump all those three together. When you're looking at troubleshooting those, what you're really looking at is software, and your solutions and what's going on is going to vary by whatever application you're dealing with. Now that we've briefly covered the OSI model, we can finally move on to talk about the different troubleshooting methodologies that are used. So as you can see here, we once again have the OSI model on the PowerPoint, and that is because the different methodologies pretty much just focus on different starting points for where you want to look for a problem. The most common type of troubleshooting is bottom up. So that means you're going to start at the physical layer and work your way up. So you're looking to make sure that everything's on, all that sort of stuff. And then once you've established the physical layer works, you can go up to the data link layer and so on. This is really good for inexperienced network admins because it doesn't take as much knowledge. You're kind of more methodically going through and trying to figure out where the problem lies. The problem with that, though, is that it is way more time consuming. It would be way easier in certain situations to shoot to the layer that you think has the problem, rather than just starting at the bottom and checking all those different connections and hardware to make sure that they're working. Inverse approach to bottom up is top down. So as you would expect, you're going to start up here with the application level and work your way down. Usually when you're going to use this, you're going to have less complex problems. If you're starting with the application or presentation layer, you're usually more focused in on a certain aspect that's not working. Whereas if you have a problem down at the physical layer and the network level layer, there's a lot of different things that could be going on wrong down there. And like I said, there's a focus on the software up here. So a lot of times it can come down to your particular domain knowledge in regards to that software and getting that problem fixed. The final of the three major branches of troubleshooting is probably the divide and conquer method. Now, this can either save you a ton of time or send you on a wild goose chase, depending upon how much you know and how good of a guess you make as to where the problem is occurring. So what you're going to do with divide and conquer, rather than starting at the bottom or starting at the top, you're going to pick somewhere to start, usually the network layer. You're going to troubleshoot there, and then from there, if you're having success at the network layer, that means your problem is higher up. So if your network layer is working, if you're able to ping and all that, you're going to be looking at a higher level problem. If you fail, you move down. So if your network layer is not working, it's either at your network layer or lower. And like I kind of touched upon, the problem with this is that it really requires a lot more knowledge. If you're jumping in at a certain place, you could be jumping in either too high or too low and really wasting a lot of time, and you might miss what the actual problem is. There are a few other methods that I will talk about briefly. One of these is follow the path, and what this means is that you're usually looking at a point-to-point connection, or where you're following the path of the traffic through a network to see where the problem occurs and trying to solve the problem there. The next would be you want to compare your network to a configuration that's already working. You want to see where your configuration might be different. And then finally, you could just flat out, if you're having a problem with a router or a certain part in your network, rather than sitting there and trying to mess with configurations or figure out what's wrong, you just simply replace the router with a new router and see if that fixes things. Depending upon where your problem lies in the OSI model, there are some commands in your command line interface that you can use to try to spot where the problem is. And I want to kind of go over some of the more commonly used ones. So first up, this is a classic, good old ping. This is just a real simple establishing connection between 2 points. As you can see here, you ping whatever you're trying, the website, IP address, whatever, and then it will send 4 packets out to it to see if it makes it there. Your next one, you're looking at trace route, and kind of exactly what it sounds like. You're going to trace your route to a certain destination, and what the result will give you is it will give you each hop along the way until it finally reaches its destination. ipconfig can be a really good command to use to just really basically make sure that whatever device you're looking at is set up correctly. You're looking at your IPv4 addresses, you're looking to make sure your default gateway is correct. This is just real basic, making sure that you've got your fundamentals correct. Another crucial tool is NSLookup, which stands for Name Server Lookup. Basically what this is doing is you're trying to make sure that the DNS server is working, that when you're entering cisco.com, it's got that configured to an IP address so that there's connectivity there. There are also several show commands that can help give you more insight into whatever certain command you're wanting to look at. For instance, the show version command will give you information about the iOS of whatever device you're using, what ROM it's using, things of that nature. The show interface command will give you information about whether an interface is up. The show IP route command will allow you to look at a router's routing table. It'll give you information about whether or not there's a connection, if it's a static connection, which is a connection that you yourself made, things of that nature. The show running config will give you an idea of what the running configuration of whatever device you're on is. It'll give you all sorts of information about interfaces, about passwords. That can be a really go-to when you're in the middle of configuring a device. And then finally, show VLAN will give you information about, obviously, VLANs. Can really help you troubleshoot those if you think that's where your issue lies. So now that we've covered some more of the more technical information, I want to go over something that's also very important, and that's and often overlooked, and that's communication. When you're communicating with an end user or a client, you want to make sure that you're not throwing a whole bunch of technical jargon at them that they don't understand nor care about. You want to make sure that you speak their language, because otherwise they're going to end up looking at you like this. An important thing in communicating problems is establishing the time frame. Like, you want to make sure that you understand when the problem started occurring, what happened around the problem, like what occurred before the problem started happening, things of that nature. And as you're questioning, you want to try to start from a broad area and narrow things down. The same way a doctor, you could go into a doctor complaining about your head hurting. That could be any number of things. You want to add to the symptoms so you can narrow it down, get the problem narrowed down to a layer or even a specific protocol that you could fix. So ultimately, I want to get across that when you're talking about troubleshooting, there's no one-size-fits-all answer. You're going to have to take everything on a case-by-case basis, and that's why when working as a networking professional, the more experience you have, the more issues you've dealt with, just the better you're going to get at it. You have that experience to go back and rely on. You've been there, done that. That can really help you out a lot. What else can also really help you out is organization. As I was talking about before with documentation, if you have everything well documented and current and all in an accessible place, it can make it so much easier to actually look at the network and address the problems. And ultimately, if the problem is beyond you, if you don't have that knowledge, and maybe you don't have a senior person to ask about, the internet can be your friend. There are all sorts of people out there asking the same sorts of questions you do, and Google can really help you out if you're trying to troubleshoot something and you don't particularly know the answer. So these are the sources I used as research in preparation for this project. And here's a little quiz. So true or false, physical topologies are mainly focused on IP addressing. That would be false. The physical topologies are more so focused on location and hardware. What is most often misconfigured at the transport layer? Like I said, there are two very often misconfigured protocols here with either access controlless and NAT. I would say access controlless are more often misconfigured. Which troubleshooting methodology is best for inexperienced network admins? As I said earlier, that would be bottom up. You're being way more methodical and you're not making too many assumptions, but it is very time consuming. True or false, if a network layer fails to work, you move down the OSI model to find the issue. So yes, that's true. So if you're at the network layer and you're not having connectivity, you're going to want to move down and see if your problem's at the data link layer or the physical layer. And finally, what show command displays the routing table? And that would be show IP route. And there are my answers, and that is my presentation on networking or network troubleshooting. Easy enough for me to say. All right, thanks for listening. Bye.